Hi, my name is Marley Fontenot. I'm in the Elementary Physics Lab class 1105 2D1, and this is my Part B submission for our group project on the speed of light. The speed of light is considered a fundamental constant of nature. Speed of light is the speed at which light waves propagate through different materials. In particular, the value of the speed of light in a vacuum is now defined as 299,792,458 meters per second. The relationship between wavelengths and frequency is CF with an upside down A. We can rearrange this equation to find the wavelength of all three frequencies. This equation relates the speed of a wave C to the frequency F and a wavelength. Some specific fields. The speed of light applies to all known fields, velocity, phase velocity, for example, imposing an upper limit on their propagation. Massless fields like electromagnetic waves propagate at the speed of light in vacuum. James Clerk Maxwell was born June 13th, 1831, in Edinburgh, Scotland. Died November 5th, 1879, in Cambridge, England. He studied at both the University of Edinburgh and the University of Cambridge. He was a 19th century Scottish physicist, and he developed a theory that explained the relationship between electricity and magnetism, and correctly predicted that visible light is caused by electromagnetic waves. Maxwell was best known for his formulation of electromagnetic theory.
Hi, my name is Adrian Hernandez, and in this class, we're talking about speed of light. And yeah, so let's go on. This is the introduction slide. The first one is introduction. So basically, we're talking about speed of light and the basic facts of speed of light. So, um, Einstein discovered that light always travels at the same speed, um, the same speed. And the definition is speed is how fast something moves, and it tells us the distance of an object traveling in a certain amount of time. And I found this picture on this website. I decided, and basically, by the picture, is that the bright lines of light come from the cars moving fast, and it and the camera caught their headlight and tail light as they went by and stuff, and yeah, so that's beautiful in the same image. That's awesome. Um, this uh, this is um, the field that I'm doing, fiber optic um, field that I picked. So basically, fiber optic is totally um, reflection and are widely used today to help cell phones, internet, um, cable, anything that you plug in that signals the communication system. So that's the next thing. And on to the last slide. This is the scientist that I picked. So I picked Albert A. Mitchelson, and he was born in Portland, land, and he died in California on May 9th, 1931. And his educational facts, he was in the Navy, and he went to school for a case school of science in at Lark University, and he also went to University of Chicago. And the research topic that Mitchell did is early steps of measuring of speed of light. So basically, he measured the speed of light, and he definitely used it in his way. And the routing mirror briefs discovered a light beam towards the distance um, stational mirror. And then the return beam reached ob- observe only if the reach uh, rotational mirror is completely aligned as the moment. By allowing the speed of light to be determined, Michelson results was 0.04 off from today's accepted value. And his fame, he was the first American to win the Nobel Prize in the scientist, earning the physics reward for his work of light and his and measuring tools. So that's all I got for you, and have a good day.
Hello, my name is Trace Anderson. This is a picture of me right here, and I'm going to be talking about the speed of light. So the speed of light is considered the maximum speed at which information or matter can travel in space-time. So basically the fastest that anything could possibly go would be considered the speed of light. There's a symbol for the speed of light, and that is a lowercase c. And so back in the day, a lot of scientists thought that light was just instant. Like there was no finite speed, it was just completely instant, but that has since been debunked. And a fun fact is that light from the sun to the earth takes 8 minutes and 20 seconds to reach the earth. So here's a picture of the sun and the earth right there. So a relevant field to the speed of light, I chose astrophysics because in astrophysics they use speed of light to measure distance. So basically they use light years to look at stars or galaxies and stuff like that. So a light year is the distance light travels in 1 year. So it's actually 9.46 trillion kilometers. A relevant scientist to the speed of light is this guy. His name is Ole Romer, or Romer. He was born in 1644, Aarhus, Denmark, and he died 1710, Copenhagen, Denmark. He studied at the University of Copenhagen. In 1676, he was the first person to demonstrate that light travels a finite speed by looking at Jupiter's moons. And I believe when he studied school, he didn't actually graduate. I think he just studied for like a year or two and then dropped out. And when he did his moon experiment, he estimated the speed of light to be about 220,000 kilometers per second, which is about around 80,000 off of what's accepted now as the speed of light. And that is what he's most famous for, is this little light experiment where he estimated the speed of light. Thank you.